continuing the theme of overcoming the challenges of scale up, we're going to hear from Neal Jakel, who's the president of Fluid Quip Technologies. So, Neal, please. There we go. Okay.
Perfect, thank you. Can you hear me? All right. I don't like to stand behind a podium. I'd rather walk around, keep it live, keep it entertaining. So I'm going to talk a little bit around scale up or really ideation through commercialization and lessons we've learned over the years from Fluid Quip Technologies and talking through kind of the various phases of from the initial lab, initial work, initial pilot stuff, and then how do you keep scaling up? And a lot of times, and you see that 10x there, I always talk about that, especially if you're dealing with liquid solid separations, you really can't scale up much more than about a 1 to 10x ratio. So when you got to go from lab to commercialization, there's multiple pathways that you have to go through. And that's a balancing act between technology mitigation versus capital outlay. And a lot of times, lots of money are put into the initial lab or initial technology development, but putting steel in the ground, that's where it gets dicey, that's where it gets challenging, and that's where you have to mitigate that risk through proper engineering and proper technology selection. And that's what we're going to talk about, some of the technologies we brought to market over the years. So with that, real quick, who is FQT? Who's Fluid Quip Technology? So we are a process engineering technology development company located in Cedar Rapids, Iowa, so 4-hour jaunt straight east of here. And the corn looks great, so there's plenty of that coming out of the fields. We have our technologies are in more than 4 billion gallons worldwide. Most of our stuff has been centered around the ethanol space. We have done more than 400 projects globally. We have a team of about 70 people, mostly in Cedar Rapids, but also here in Omaha. Our projects that we've done have been about $1 billion worth of capital invested over the last 15 years. So that has given us a lot of learnings and a lot of opportunities to help mitigate risks on things that you're trying to do, things that you're trying to scale up, and that's what we're here to do. We can help you get to that commercial faster, or get to the commercializations faster. So, with that, we do have a team. I always have to put this photo in here to show you we do it. We are not AI. We're not robots. We do exist. But our engineering team and our technical team, we have about 20 plus years of average experience. And what I always like to tell people, we know what not to do. We have a lot of learned failures in our team, which benefits you when you're looking to scale up and you're looking to commercialize your technology. We can help you get to that yes quicker because of those learned failures that we've had to, fortunate or unfortunate, however you want to look at it. Like I always tell my team, fail quick, fail often, just don't fail twice. With that, we also have a lot of supporting team. We also do our own design, our own CAD modeling, our own 3D modeling of the technologies that we not only develop in-house, but also work with other partner companies on as well. Our strength, I would say, is around separations. We know how to separate stuff really, really well. So if you got a challenging product or solution you need help with, that's really where we come into play in terms of figuring out the different unit operations, the different technologies, the different pieces of equipment out there. So I'm going to go all the way back to the beginning a little bit here. I talked about ideation, lab scale, all the way through commercialization. And one of the things I see a lot when we talk to folks that are in the bio everything space is around the feedstock. And I always hear people, oh, we're just using sugar. We're just, dial up 1-800 Sugars R Us and ship us sugars. The problem I have out there is there's a lot more out there than just sugars, right? Now carbohydrates are everything. Corn is actually a great 4-letter word. Besides, some people think there's a negative connotation to it, and they always want waste streams. But corn is a great carbohydrate resource, and it's really the center of this diagram when you think about all the things that you can do with a carbohydrate. But there are other things out there. There's fibers, there's oils, there's waste pulp products, things like that. You need to evaluate that earlier in the stage. That's one of the things we see out there a lot is people get fairly far down the development phase, and they really never thought about their actual raw material in terms of what does it look like? Are there other feed materials? Are there better feed materials? Are there feed materials that may be lower cost but may have other components in there? And how does that impact the downstream performance or the bugs? So there's a lot of questions I would pose to folks earlier to ask this question and really think through pricing, availability, things like that. Why does that matter? So when we look at the corn world, when we look at the grain world or the carbohydrate world out there, the bio everything economy is mostly centered around carbohydrates. I would say vast majority, and what Nico had just showed up there a little bit ago, and I forget the gentleman's name from Premiant. Those are all carbohydrate-based fermentation processes. They start with a carbohydrate, and to that point, we heard some things about the U.S. ethanol and the farmer and tracking, and the U.S. the ethanol, global ethanol product is a huge sugar producer, but they don't actually make sugar, right? They actually consume it and convert it to ethanol and CO2. However, those bioethanol plants also need diversification because the margins in ethanol aren't the greatest. And so one of the things that these ethanol plants can look at is what else can they make besides ethanol? Sugar's one of those things, and I'll talk a little bit about that. On the flip side, you've got the big players out there, the Cargills, the ADMs, the Tate & Lyles, or Premiant, ingredients that are making, they're the main sugar producers for a lot of the fermentation processes. However, the supply is limited. There's not a new wet mill that's been built in the U.S. in almost 20 plus years. I think Fort Dodge might have been the last one. And so they're very expensive, which means it's very expensive to get that carbohydrate. The point I'm getting here is that there is other ways. There are other solutions to get a low-cost carbohydrate to your fermentation processes. And when you think about it, and again, it gets back to that earlier slide, fermentation process, your cost, your COGS, could be upwards of 70% is your raw material. So one of those things to really focus on that early on is what is that raw material, where are you getting it from, and what's the cost. And this is just an illustrative slide of one of our technologies we have out there called Clean Sugar Technology. It's the ability to produce sugars. We do it at a bioethanol plant where basically, you can still make ethanol, but you can also make sugars. And it shows you that if you do a techno-economic analysis, we could produce these sugars at a lower cost than a traditional wet mill or other producers out there. But it's also produced at a lower carbon footprint. That's the big thing. So now you actually have a price premium or a price reduction, but you also have a value driver because the carbohydrate or the carbon intensity of that carbohydrate is much lower than the traditional methodologies out there. And that's a game changer when you start adding up all that carbon footprint. And raw materials, a large portion of that carbon footprint of your process, you want to start with as low carbon material as possible. And that's one of the technologies that we have out there. So how did that come about? Well, it took us about 10 years to get there from the initial ideation of this technology, of this clean sugar technology, back in a lab when we were trying to produce starch at a wet mill or at a dry corn ethanol plant like a wet mill does. And going through the whole analysis, we're like, well, why do we care about starch? A wet mill does a great job at producing starch. We don't care about starch. We care about dextrose. We want the end product. And so over iterations and lab experiments, we basically figured out, hey, we can make sugars and then separate those sugars from the process and feed it into these bioreactors and also ethanol. And so over the years, we basically de-risked the technology by starting in the lab, moving to a pilot, doing a lot of the engineering work around figuring out what are the technologies, what are the right solutions. And we went through a lot of different technology iterations, a lot of equipment selections to figure out how to get to the right process with the right carbon footprint and the right yields. Ultimately, getting to a pilot facility out in York, Nebraska here. It's about a 2-hour drive due west of here. And then eventually partnering with our parent company, Green Plains, built the full-scale commercial system in Shenandoah, Iowa, which is about an hour, 10 minutes south of here, and truly integrated that bio concept together in that facility where we put the clean sugar technology with an ethanol plant. And then again, though, it took us 10 years to get there and a lot of capital. And the key here, though, is risk mitigation all the way through that. So I talk about this at a high level on the biocampus, and what does that look like, and why does that matter? We heard conversations earlier here around the third-party CMO facilities or some of the wet mills out there. But when you think about it, an ethanol plant, there's 200 here in the U.S. It really allows diversification, as well as the ability to co-locate where you want to co-locate, where your product makes the most sense. And whereas an ethanol plant does have a lot of sugar available, we can bolt on technologies to help produce those sugars for you. And again, we see the carbohydrate revolution coming. We think that more and more of these products are going to be carbohydrate based. Yes, there'll be some that are fiber, some that are oil, but the vast majority are carbohydrate based. And you need a low CI, and you need to be integrated. Because why would you want to have to put in all that extra capital for utilities and roads and infrastructure when a lot of the biocampuses, a lot of these ethanol plants have that today? Reduce your costs, reduce your risk, reduce your mitigation is what we're looking at. So with that, it all starts back at the beginning. As I said, we're a process engineering company. Our focus is around how do we ensure the design works from the start. And again, we follow this process, this front-end loaded process, and a lot of people say, well, I just want to skip it. I just want to jump to the end. The problem is when you're jumping to the end, that's where you have problems. That's where you have risks. That's where you have unknowns. And yes, this may take a little bit longer, but as you go from FEL 1 to 2 to 3, you're constantly de-risking the project. And what you're also doing is, and this just gives you an example of the output, as you move from left to right, from the ideation stage to the finalization stage of that engineering design, you're also reducing your capital cost, and you're reducing your capital cost risk mitigation. So it all starts, to me, with the process engineering. All the other engineering, commodity engineering, that's easy. You got to get the process right. And you want to work with people that have been there, right? Have those known failures, know how to design things, know how to design risk, know how to design waste out of the system. So when we look at our engineering and when we work with a client around how do we reduce risk, starts with the mass and energy balance, and then we overlay different technologies, different programs, different tools that we have to leverage how do we design the right system, the best system, the smartest system for you. And from there, we also look at, okay, how else do we integrate other technologies, other integrations? How do we look at energy? Is it nat gas? Is it solar? Is it electric? Do we want to go fully electrification? Do we want to put mechanical vapor recompressions everywhere versus steam? We've got a design. A company wanted that. They want to no nat gas for the site. It's 100%. It's an ethanol plant. It's 100% design on electric generation of the process. So then we say, okay, what else besides the process engineering? You also got to look at the other components that come together when you're looking at scaling up a technology, and that's around, okay, what is the balance of engineering? How do we smartly design the system? How do we integrate with an existing plant if we're co-locating at a biocampus? Things like that. Also, we have partnerships with a lot of the major enzyme and chemical companies to also look at where do we integrate that? How do we integrate those other systems into the equation? And I think the last one here, this equipment manufacturer, that's probably the one big thing is we're not just an engineering company. As I said, we're a technology company, but we also work really close with a lot of the equipment suppliers to make sure that their equipment is designed properly for your system. So we work with companies like Alpha LaValve and Dietert and Comline and others. And for example, that dryer there up in the upper left corner, that's a Dietert ring dryer. That's not a standard. That's for a high protein product we produce at an ethanol plant. That's not a standard ring dryer. We actually went in there and said, hey, for this particular protein, it's a little unique, a little different. We got to modify this dryer. So our team went in and worked with Dietert and modified the dryer. So we have a lot of embedded IP in some of these equipment manufacturers because we know exactly what needs to get done. How do you make that final product? So it's not just the engineering up front. It's the engineering all the way through the chain that's critical. Some of the other things that we bring to the table too, just as I mentioned, we have a lab here in Omaha, and then we also have the pilot facility out in York, Nebraska, which is about 2 hours here, which is one of the Green Plains facilities there. And so we can work with you on lab scale simulation. It's amazing what we can do on solid liquid separations, distillations, things like that, fermentation at the lab scale, and then take it to our pilot scale. Again, it's de-risking each of those stages along the ways. Again, just our technical support. We've got a team that here in Omaha and out in New York that will give us your problem. We love to solve problems. And I think that's one of the unique differentiators, because a lot of our engineering talent that we bring on board has been in your shoes. They've been in production. They've seen things. They've scaled up stuff globally, not just here in the U.S., but global presence. And so in the end here, really when you think about what is needed for successful commercialization, starting at the beginning, we can't push enough. I know there's a lot of smart people here that love to play in the lab and design experiments, but you got to get it out of that beaker as fast as possible to de-risk it. And that's where we can help on the engineering side. Also, when you're doing, how do you scale it up? You got to do 3D modeling. Right? How does everything interconnect? One of the things is it's kind of the ripple in the pond effect. If you push on this part of the process, you have to understand what's going to happen over here. And that's where that advanced modeling and other tools come into play. I would say then on our R&D side, I think right now we have 85 issued patents for our company. So there's a lot of innovation we bring on new technologies, how to separate proteins, how to purify streams, things like that. And again, also look at energy integration. That becomes a more and more a bigger and bigger driver on the energy side, is because it's not just, hey, can I make this product? What's that carbon footprint of the product? How do I mitigate that carbon footprint all the way through the entire process? And again, as I said, we have a global presence. We've got projects around the world: Brazil, South America, Europe, U.S., and then also we do a lot of turnkey projects. Here in the U.S., we've done about $1 billion worth of capital here in the U.S. and around the world. So with that, I'm going to one last slide. Again, just kind of coming back to the beginning here around integrating that engineering and technology early in the process. What is your feedstock? Where are you going to pilot this? Right? We heard some presentations of Europe does a great job at CMO. I know we've got, I thought I saw Mark here, Liberations Labs building facility here in the U.S. We need more of those facilities. There are quite a few. A lot of universities have facilities. We can work with you and those universities in terms of how do you de-risk the process? How do you ensure your capital is well spent? Because if you can't just go from lab to commercial, that would be great, but we would all love to be able to do that. But you got to go through these steps. You got to de-risk, and having a strong engineering partner with you along the way is absolutely fundamental, and in my opinion, and I think in yours, hopefully yours as well. So with that, we'll leave it there. Thank you very much. I'll be around if you have any questions.